Hello friends, I am Professor Sam Malvia. I am deliver this video on the topic brakes and dynamometers. The contents of my video is introduction of brake material for brake lining, types of brakes, single block or shoe brake, pivoted block or shoe brake, double block or shoe brake, simple band brake, differential band brake, band and block brake, and dynamometer. First, introduction of the brake. A brake is device by means of which artificial frictional resistance is applied to a moving machine member in order to retard or stop the motion of machine. In this process of performing this function, the brake absorbs either kinetic energy of the moving member or potential energy given by objects being lowered by hoist, elevator, etc. The energy absorbed by brake is dissipated in the form of heat. This heat is dissipated in the surrounding air or water which is circulate through the passes in the brake drum, so that excessive heating of brake lining does not take place. The capacity of brake depends upon the following factors: the unit pressure between the braking surface, the coefficient of friction between the braking surfaces, the peripheral velocity of the brake drum, the projected area of the friction surface, and the ability of the brake to dissipate heat equivalent. Material for the brake lining. The material used for brake lining should have the following characteristics. It should have high coefficient of friction with minimum fading. In other words, the coefficient of friction should remain constant with change in temperature. It should have low wear rate. It should have high heat resistance. It should have high heat dissipation capacity. It should have adequate mechanical strength. It should not be affected by moisture and oil. Types of brake. According to the means used for transforming the energy by the braking elements, they are classified as hydraulic brake, electric brake, or mechanical brake and mechanical brake. Hydraulic brakes, example, pump or hydrodynamic brakes, tube agitators, electric brakes, generator and eddy currents brakes, etc. and mechanical brakes. The mechanical brake may be classified according to the direction of acting force, may be divided into two groups: radial brakes and axial brakes. Radial brakes, in these brakes, the force acting on the brake drum is in radial direction. The radial brake may be subdivided into external brake and internal brake. According to the shape of the friction element, these brakes may be block, shoe or shoe brake and band brake. Axial brakes, in these brakes, the force acting on the brake drum is in axial direction. The axial brake may be disc brake and cone brakes. Single block or shoe brake. Let me describe the construction of the single block or shoe brake. It consists of block or shoe which placed against the rim or the revolving brake wheel drum. The block is made up of softer material than the rim of the wheel. This type of brake is commonly used on railway train and tram cars. The friction between the block and the wheel causes a tangential braking force to act on the wheel, which tends to retard the rotation of the wheel. The block is pressed against the wheel by a force applied to one end of the lever to which the block is rigidly fixed. The other end of the lever is pivoted on the fixed fulcrum. This is the diagram of single shoe brake or brake block brake, and this is the notations which are used for derivations of the braking torque of single block or shoe brakes. Braking torque T is equal to FTR, that is equal to mu Rn. Mu is the coefficient of friction, Rn is the normal force, and R is the radius of the wheel. If angle of contact is less than 60 degrees, then it may be assumed that the normal pressure between the block and wheel is uniform. Pivoted block. When the angle of contact is greater than 60 degree, then the unit pressure normal to the surface of contact is less at the ends than at center. In such cases, the block or shoe is pivoted to lever instead of being rigidly attached to the lever. This gives uniform wear of brake lining in the direction of applied force. The braking torque for pivoted block or shoe brake when 2 theta is greater than 60 degrees is given by this. T is equal to Ft into R, that is mu dash Rn into R. Mu dash is equivalent coefficient of friction. This is equal to 4 mu sin theta upon 2 theta plus sin 2 theta, and mu is the actual coefficient of friction. This is the diagram of pivoted block or shoe brakes in which the block is not fixed on the lever but it is pivoted on the lever. Double shoe or block brake. When a single block brake is applied to a rolling wheel, an additional load is thrown on the shaft bearing due to the normal force Rn. This produces bending of shaft. In order to overcome this drawback, a double block or shoe brake is used. It consists of two brake blocks applied at the opposite end of the diameter of the wheel, which eliminate or reduce the unbalanced force on the shaft. The brake is set by a spring which pulls the upper end of the brake's arm together. When a force P is applied to the well cranked lever, the spring is compressed and the brake is released. This type of brake is often used on electric cranes, and the force P is produced by an electromagnets or solenoids. When the current is switched off, there is no force on the well crank lever and the brake is engaged automatically due to the spring force, and thus there will be no downward movement of the load. This is the diagram of double block or shoe brake. In double block brake, the braking action is doubled by the use of two blocks, and these blocks may be operated practically by same force which we operated one. In case of double block or shoe brake, the braking torque is T is equal to Ft1 plus Ft2 into R. Ft1, Ft2 are the braking force on the two blocks. Simple band brakes. Simple band brakes. A band brake consists of flexible band or leather, one or more ropes or a steel lined with friction material which embraces a part of the circumference of the drum. A band brake is called a simple band brake, in which one end of the band is attached to the fixed pin or fulcrum of the lever, while the other end is attached to the lever at distance B from the fulcrum. When force P is applied to the lever at C, the lever turns about the fulcrum pin O and tighten the band on the drum, and hence brakes are applied. The friction between the band and the drum provided by the braking force. The force P on the lever at C may be determined as viscous. T1 is the tension in tight sides, T2 is the tension in slack sides. Theta is the angle of lap or embrace, U is the coefficient of friction, R is the radius of the drum, thickness T is the thickness of the band, RE effective radius of the drum, that is equal to R plus T by 2. This is the diagram of the simple band brake. So in band brake, the braking torque comes out to be T1 minus T2 into R, neglecting the thickness of band, and T1 minus T2 into RE, consider the thickness of the band. Differential brakes, band brake. In differential band brake, the end of the band are joined at A and B to a lever AOC pivoted on a fixed pin or fulcrum O. This is the diagram of differential band brake. It may be noted that for a band to tighten, the length AO must be greater than the length OB. The braking torque on the drum may be obtained in similar way as discussed in simple band brake. Now, and this is the derivations how to we get the T1 and T2 by taking movements question. Band and block brakes. Band and block brake may be lined with block of goods or other material. The block of wood or other material, the friction between the block and the drum provide braking action. Let there are n number of blocks, each subtending an angle of 2 theta at the center, and the drum rotating anti-clockwise direction. These are the notations which are used for derivations of the braking torque. T1 is the tension in tight side, T2 is the tension in slack side, mu is the coefficient of friction, T1 tension in band between first and second block, and similarly. So the ratio between T1 and T2 comes out to be 1 plus mu tan theta, 1 minus mu tan theta to the power n. N is the number of block. Braking torque of effective radius RE, TV is equal to T1 minus T2 into RE. Next topic is dynamometer. A dynamometer is a brake, but addition to it, it has a device to measure the frictional resistance. Knowing the frictional resistance, B may obtain the torque transmitted and hence the power of the engine. By dynamometer, we can find out the power of engine. Types of dynamometer. Dynamometer may be classified as two types. One is the absorption dynamometer, and second one is the transmission dynamometer. In absorption dynamometer, the entire energy or power produced by the engine is absorbed by the frictional resistance of the brake and is transferred into heat during the process of measurement. But in transmission dynamometer, the energy is not wasted in friction, but it is used for loading work. The energy or power produced by the engine is transmitted through dynamometer to some other machine where the power developed is suitably measured. Absorption dynamometer is of two types: Prony brake dynamometer and Robb brake dynamometer. A simple form of Prony brake dynamometer, a simplest form of absorption type dynamometer, is a Prony brake dynamometer. It consists of two wooden blocks placed around a pulley fixed to the shaft of an engine whose power is required to be measured. This is the diagram of Prony brake dynamometer and the construction given shown in this diagram. This is the notations which are used for the calculation of brake power. Brake power comes out to be WL into 2 pi N by 60 watt. W is the Weight at the outer end of the lever in Newton. L is the horizontal distance, F is the frictional resistance, R is the radius of the pulley, and N is the speed of shaft in RPM. Next is the rock brake dynamometer. It is another form of absorption type dynamometer which is most commonly used for measuring the brake power of an engine. It consists of one, two or more ropes wound around the flywheel or ring of pulley fixed rigidly to the shaft of an engine. The upper end of the rope is attached to spring balance, while the lower end of rope is kept in position by applying a dead weight in order to prevent the slipping of the rope over the flywheel. Wooden blocks are placed at interval around the circumference of the flywheel. In operation of brake, the engine is made to run at constant speed. The frictional torque due to the rope must be equal to the torque being transmitted by engine. This is the brake power W minus S by dN by 60 watt. Thank you very much.